Hello everyone, my name is Jankara. I and my colleague Aminreza Iranmanesh would like to present our study which is called Protection Area Boundary Development by using AHB and GIS in Historic Cultural Heritage Areas. Our study presentation includes, first of all, problem definition and background related to cultural heritage boundary development, study area, which is Lapta and Alsancak region in northern Cyprus, methodology parts, analytical hierarchy process and geographical information systems, results, discussion and conclusion parts. As we all know, protection areas or protection boundaries are very important urban elements that are designated areas intended to protect historic built environments and natural resources, control urban sprawl, and also promote sustainable development within urban zones. According to the Sustainable Development Goal 11, it is important to protect historic urban environments. In northern part of Cyprus, there are many historic urban elements and unfortunately they don't have any protection plan or protection boundaries. The historical urban environments of Lapitos and Karavas are important for their cultural and social significance. These areas were once home to diverse communities including Greek Orthodox, Maronite and Turkish Cypriot populations, who coexisted in relative harmony for centuries. The architecture and urban layout of these areas reflected the complex social and cultural history of the region, which has been shaped by various influences over time. The historical urban environments of Lapetos and Karavas are important for their potential as tourist destinations also. These areas are rich in cultural heritage and they offer visitors a unique opportunity to explore the history and architecture of the region. You may see from the pictures on the right side, it's a study area boundary. It covers the Karavas and Lapetos villages and traditional and historical urban fabric zones. Also, you may see some examples from the streets weave from the Karavas and Lapitos region. They have many important historical urban elements need to be protected. So it is important to ask how we can develop protection area boundary or how we can manage this decision-making process. As we all know, analytical hierarchy process is a multi-criteria decision-making method that has a potential to address intrinsic complexities of the problem. Since the protection area boundary development is a complex process, we decided to using analytical hierarchy process for managing the decision making. For the complex process, we need to understand the problem. We need to understand the problem parameters. We call them like criteria. We need to decide which criteria as the importance of the criteria, which elements or part of sub-criteria can be used for the decision-making process. So basically, we adopt the Malchevsky multi-criteria analysis flow according to our project. For setting up the hierarchy, like we proposed in the main methodology, we decided first of all the parameters of the protection of historical, cultural, urban environments. They are like economic dimensions, architectonic, environmental, social, and legal parameters. It needs to be included for developing the protection area boundary. We call them as a main problem as a protection of historical environment, and these problems includes also decision criteria. We call them economic, architectonic, environmental, social, and legal, and they have also sub-criteria, functional change, structural condition, like the architectural values like monumental, aesthetic, contextual, compatibility, contrary. Also, we are using some sub criteria like protection, green area, pollution effects, public interest or ownership, like this. And also we have some criterion elements, like for example, if we have structural condition, bad condition, good condition, or ruin. We use all of them to improve the hierarchy and model for analytical hierarchy process. After setting up the hierarchy related to the main problem, we need to develop the comparison matrix by using hierarchy elements like criteria, subcriteria, and criterion. So here is one example. We are using 10 expert in order to understand which parameter or which criteria has high importance or low importance according to the each of the element. For example, here you can see the example comparison of main criteria. After the comparison process, we obtain all criteria weights for the main criteria, subcriteria, and also other criterion details, like if we have a structural condition bad, or if we have structural condition good or ruined, or if we have functional details like housing and touristic or commercial functions. All of the details have obtained according to the expert comparison matrix. Social main criteria has the highest rank for this study area. You can also see the sub-criteria details like functional change. For example, functional change has the housing and commercial and touristic criterion. They have all different weights, and all these touristic criterion has the highest values for the in terms of total. Since we develop the criteria weights for each element, we need to obtain them as a GIS layer, and then we need to convert them to the criterion map. For example, we collect the data related to architectural or structural condition related elements. We put all the conditions for each building. Then we create a database. Then all the database are using the structural weight of the criterion. Then we convert them to the criterion map. While we convert them to the criterion map, we are using the parcel units. We are using, for example, building units, inputting the data about structural condition. Then we put the criteria weight. Then by helping the geographical information system, we are representing analytic hierarchy process comparison weights into the GIS maps. For example, this is the structural condition criteria map. As you notice, higher values or higher weights represented in the darker colors on the ground for the Karavaz region and Lapta region. After the development of criteria layers, all criteria layers need to be integrated into the single composite map for showing us the final criterion weights. In order to do that, we're using the raster calculator in the GIS environment. We combine all of the criteria into the single layer as a result map for showing the protection boundary values. Final result maps, which is developed or obtained by all spatial criteria and values of AHP, shows us the higher and lower zones for protection values. As can be seen from the map, there are many important zones and small areas need to be protected. Not all the study area maybe, but simple areas need to be protected immediately according to the AHP and GIS-based study. As we mentioned above, this study is using AHP and GIS for decision making on protection zones and boundary for Leptos and Karavaz region in Cyprus. We would like to emphasize that data availability is key for building up the model and criteria selection. Particularly for the GIS studies, it is really important to obtain the data from the ground for architectural values, structural condition, function, and other dimensions of the hierarchy that is set up in this study. More importantly, sometimes inherent characteristics can be added as criteria or sub-criteria for the model improvement. Sometimes criteria or dimensions cannot be unique for the specific zones, so we may not able to use the similar criteria or criteria layers or sub-criteria for the different regions and different cities. We all know that AHP pairwise comparison may have different results according to different experts also. So pairwise comparison may change in some other countries or according to different expert. Like if we're using 20 expert, criteria weight may little change or may change according to the expert choice. Most importantly, sensitivity analysis should be adopted for decision-making process or planning application as further step. As Malchevsky mentioned that sensitivity analysis need to be repeated before giving the final decision for the study. We would like to thank you for listening us today, and we would like to thank to Lapetos and Karabas local experts and all other experts that support this study. Thank you so much.